Embeddings, an AI term that you've probably heard before, and if you're anything like me, you glossed over it because you thought it was too technical. In this video, we're going to explain what embeddings are for the non-technical folks out there and how they play a crucial function in how AI operates. For most of computing history, search didn't understand you. It matched you, letter by letter, against what was stored in its system. You search for a couch, but the site only listed couches as sofas. 0 results. The couch was there. They had couches. Your search just couldn't find it because you didn't say the magic word. Say the right thing and you get the results. Sofa. Say anything else and you get nothing. The system required a bullseye every time. 1 inch off, and it was the same as a mile off. In 2013, a team at Google published a paper. They built something called Word2Vec, trained on roughly 100 billion words from Google News. And what it produced, quietly, was the first working solution to the magic word problem. Their idea was to give every word a location in space. Not a folder, not a tag, a position, a point in 3-dimensional space, sort of. Words that mean similar things get positions close together. Words that mean different things land far, far apart. Now let's take a step back from the board. Every word ever written has already been thrown. And they didn't land randomly. They landed near the words they appear with, near the context that they live in. Couch and sofa and settee are clustered together because people use them in the same way, in the same types of sentences, about the same things. King and queen and prince are another cluster. Code and function and algorithm are somewhere else entirely. The dartboard, zoomed out, is a map of meaning. That is embedding. A location, a position that stands for meaning. Similar things are neighbors and different things are far apart. Simple. Nobody filed those words. Nobody decided that couch belongs near sofa. The model figured it out itself and learned to map by reading text and asking the same question over and over. What words tend to appear together? Usage determines location. Location carries meaning. And nobody designed that. It just emerged. When you type in a question, your question gets a location too. And instead of hunting for an exact match, the system looks around. What's nearby? What's in this neighborhood? Those are your results. You don't need the bullseye. You just need the neighborhood. Spotify is a great example of this. They use embeddings for every recommendation you've ever received. Every song on Spotify has a position on their embeddings map, not assigned by genre or artist, but learned from how people actually listen. Songs that appear together in the same playlists land near each other. Spotify's own researchers call these positions track zip codes. 2 holiday songs share the same part of their zip code because they live in the same neighborhood. That's why Discover Weekly can hand you a song that you've never heard and somehow it just fits. It's not matching titles, it's navigating by zip code. You are already inside of this ecosystem. Every time an AI assistant tries to find the right context from a conversation you had, say, last week, not because you used the same words, but because you meant the same thing, it's using embeddings. Google Photos understands beach at sunset without reading a file name. Teams finds a message from 6 months ago when you searched for something you never called it. The meaning wasn't captured when you weren't looking. It was captured the moment the message arrived. By the time you typed anything, the map was already drawn. But you can also build your own. Take an image library. 2,000 images, each with a descriptive file name. You run those through an embedding model, Claude, or any embedding API. Each image gets its own coordinates, and those coordinates go to a vector database that runs on your machine. And when you search something like character near a screen, looking uncertain, your words get coordinates too. The system finds the nearest images, not by file name, but by meaning. So you need 3 things here: your content, an embedding model, and somewhere to store the coordinates. That pattern works for anything: documents, research notes, every script you've ever written, images, like I said before. Give them coordinates and you can search specific things like which episode covered the danger of confident wrong answers. And it can find the right one, even if you didn't use those exact words. In Teams or Google Photos, you never triggered any of it. You didn't create those embeddings. The embeddings happened the moment the content arrived. Someone else built out that pipeline. So when you build your own and you need to do your own embeddings, you'll run it once. You'll feed your content through the model and store those coordinates in a plain file on a local database or a Notes app that will handle it quietly for you. Something like Obsidian does this. It's a note-taking app that lives entirely on your own computer. With a semantic search plugin, it embeds your notes automatically and stores the coordinates inside your vault. You set it up once, and after that, your notes are searchable by meaning, not by exact words. You used them when you wrote them. One pass to build the map, and after that, the map draws itself. The map is only as good as what built it. Embeddings learn from human data, which means they pick up human patterns, including the ones we'd rather not pass on. Two things can end up as neighbors on the map because of how we've historically used them, not because they logically belong together. The model doesn't know the difference, it just knows the distance. And a dart that lands in the wrong neighborhood returns confident results anyway. The map finds the nearest thing. It doesn't check whether nearest happens to be right. Old search matched the word itself. Embeddings match the meaning. The machine stopped waiting for you to say the exact right thing. It learned the neighborhood instead. And when your question lands close enough, it finds what you were after, even if you never said the magic word. When a search returns the right result, even though you phrased it differently from how it was written, that's the map. When Spotify hands you a song you didn't know you needed, that's the map. You're no longer looking for a bullseye. You're just wandering the neighborhood.